before I start this video, I really want to give you this giant inverse notation warning. And in this video, we're going to talk about how do I use a composite function to verify inverses. But before I'm able to do that, I just want to give you this big old warning, right? So something that I think is particularly confusing, and rightfully so, is that if I were to write f of x equals x plus 3 quantity to the power of -1, what does that mean? That means that all of this stuff is raised to the power of -1, which means that this is 1 over x plus 3. Now, this is not an inverse. This, just to be really, really clear, this is not an inverse. This is not what inverse means, yet the notation uses an exponent of -1. In this class, and in your future classes, a lot of mathematicians will write f to the power of -1 of x. And that means, and they'll say, hey, like they'll say that equals x plus 3. These are not equal. These are not the same. Not the same. I want to make that abundantly clear. And what this is saying, what this green stuff is saying, is it's saying, hey, the inverse of the original function f of x is x plus 3. So just some warning here that when I write it with the -1 in the function notation section, this is saying, hey, this is an inverse. So just rewatch this section if I confused you, or ask me about it. But I don't want you to make the assumption just because it has a -1 means that it's an inverse. Okay, it doesn't. Be really careful at the notation and analyze like what's different inherently about this stuff with the -1 as a part of the function versus -1 being a part of the function notation, the way that we're writing it. So when you probably learned about inverses, you learned about them with numbers and just regular whole numbers. And so a lot of the times I use a whole number example to kind of prove a point. If I'm thinking about the inverse of 2, it's a half, because 2 times 1/2 is 1. But in algebra, we want to find things that create something called an identity. The thing that I go in does an inverse is kind of an undo function. So like 2 undoes 1/2 and 1/2 undoes 2. Well, when I'm thinking about inverse functions, I want to think about what undoes and how can I prove that it undoes. So we'll use composition functions to do that. So at this point, I'm presenting you with two different functions, f of x, which is 2x plus 5, and g of x, which is 1/2 x minus 5 over 2. And I'm claiming that these are inverses of one another. And how do I prove that? Well, I'm going to prove that these are inverses of each other by doing two different things. I'm going to say f of g of x, so that's an inverse function, or excuse me, a composition function, and hopefully we'll see, does it equal x? If it is a composition function, it will equal x, and so we'll do a bunch of work to make that happen. But on the other side, we also need to have the opposite way be true. We also need g of f of x to also equal x. And if both of those are true, then we would say that f is the inverse of g and g is the inverse of x. So we kind of have to do it both ways. So we talked about composition functions in that, the g is on the inside, so I'm going to do f of, and I'm going to do g, which is 1/2 x minus 5 over 2. And what is f? F is 2x plus 5. So 2 times stuff plus 5. So 2 times stuff plus 5. So in that stuff, instead of x, 1/2 x minus 5 over 2. If I distribute that 2, this becomes 1x minus 5 plus 5. Hey, look at that. It equals x. That's a good sign. We'll do the same thing on the other one. G of f of x, well, what's f of x? F of x is 2x plus 5. And g of f of x says, okay, that's 1/2, what's g of x? G of x is 1/2 times x, so 1/2 times the stuff minus 5 over 2. Now this one's going to be a little bit more more complicated. So x, the stuff that goes into g, is 2x plus 5. So I'm replacing every x with the stuff that went into g. And we'll need to distribute, so a half times 2x, ooh, that's nice, that's just x. A half times 5, okay, that is 5 over 2. 5 times a half is 5 halves. And then minus 5 over 2. Hey, look at this is really nice. It equals x. So because when I do the composition both ways, both equal x, we would say that f is an inverse. F is the inverse of g. And we could say the same thing the other way around. G is also the inverse of the function f. Okay, we'll talk about it a time when that doesn't happen, just so that you can see what to look for. So we've got two functions, f and g, and we want to see if they're inverses of one another. And so we need to do two things. We need to do f of g of x, and we need to do g of f of x. G of f of x. We'll write it in this notation just to kind of review some of the notation that we've been doing. So what does this mean? This is saying f has a g inside of it, and in this one we're saying g has an f inside of it, where the input is x. Okay? So I'll try and colorize these now. So f of g of x, well, what's g of x? G is the square root of x minus 5, and that minus 5 is outside of the square root. Just be aware of where that negative 5 is. And so we'll do this first one first. So f says f squared. Oop, goodness, I'll do it. We're saying x squared, so stuff squared plus 5 times that stuff. Now in this case, there's two x's, so I've got to replace the x both times. Okay? And we're going to say, hey, like, if this equals x, that's a good thing. So this is a square, so this is saying, hey, let's do it. Square root of x minus 5 times the square root of x minus 5. And with the magic of, multiplying, we get x minus 10 square root x plus 25. And so then this is plus 5 root x and negative 25. So plus 5 root x minus 25. So I'll combine like terms and hopefully things will simplify. So positive 25 and negative 25 cancel out. Negative 10 times root x plus 5 root x. So this is x minus this 5 times the square root of x. This doesn't work. We know, based on this solution, it doesn't equal x. F and g are not inverses of one another, and I'll prove it to you by doing the second one. Maybe this is a good opportunity to pause the video and try your hand at these composition functions. Some of them can be a little bit tricky. So pause the video, and I'll be back in just a moment. All right, hopefully you've had a chance to do it. So we'll give it a try. So g of f of x, where the input into g is f. So x squared plus 5x. And g is saying the square root of stuff minus 5. The square root of stuff, where the stuff is the input, minus 5. And let's see, how does that work? So x squared minus 5x. Ooh, goodness, this gets nasty really quickly, doesn't it? And in fact, this isn't even, you can't even move forward on this, right? Because we don't actually know, and it's not really possible unless we know what x is, to simplify this anymore. So based purely on this, since we can't simplify it, not to say that you should stop when you can't simplify something anymore, but really we are totally out of options. We've exhausted the options. And so we can definitively say, because when I do f of g of x and I do g of f of x, we don't get x. This doesn't work, and these red x's are like no's. No, these are not inverses of one another, and so here's how you check. Thanks for watching this video. Replay it if you need to review a little bit of something. I hope it's helpful, and I'll see you in the next one.